Hello, folks. Line 23 in AR. Really? Okay, we have a type definition there. For lives equal, that's failing, which is okay. For other things, it is not. And that's kind of fine. So we're going to go to an example and we're just going to put our function here because that's really the one we want to see. I like just a little when I said I need you. You stretched the truth when you said what you knew. Just can't believe it. So we have a return type here, which is fine. And now we actually want to go over the arguments, right? Parameters. And we're going to do a match on event type parameters, right? If we get none, that's fine. We're going to go with none, or rather an empty list. If we do get some here, then I want to know what the hell we're going to do with that. Because my guess is that this is also a list, but I'm not sure. So let's see parameters. Hey Diego, ¿todo bien, hermano? Living alone, falling from grace. Okay, there's a bunch of includes here. We're not gonna find what we want. That sucks. Well, we know it's an option. Let's browse the sources and see if we find something there. Estamos en un detour. Told me to go. Then asked who's to blame. I don't know. Okay, so parameters can be non-variadic. Right, we have this stuff to deal with. I wonder how we would do that. Not coming back. Beep. There we go. This is what I want. So we have parameters, and they can be non-variadic, or I guess variadic as well. Looking back at what he left, the list of plans. Decoration. We want to pattern match in that description. There you go. Qualify type, the name, and default if he has a default value. We will ignore this for now, and we're just gonna go for qual type, right? So we want to put together a function, a param really, which is gonna be name, which I think is a string. Yep. So name, and then we'll do lift type, qual type. So we'll just do return a tuple there, and this is gonna come from here, param desk like that. Lift type, cool. Param desk. So now we can have that, which I like, and we can put together our function type, right? Which we need here. Function declaration needs to have a function type, right? Func of return, and we need an ER type there, and we need fun params, and we need an ER type list. So we can now do fun ret, right? Fun params. Fun params. And we're gonna call that fun ret. So now that should return what we expect. Function type. Why don't you like that? Didn't we just call it that? Oh, sorry. It's func. Like that. Fun params. And this should actually be a list of string to type. So that. Cool. I should compile. Shouldn't do much right now. We have an exception still. Right. So at least we have a type now. So now we can come up with a function declaration, right? And this will have other things. Like we need a fundacle. Name, and we need a fundacle. God damn it. Type. So let's add that here. We so far have an ER for a type, but we need fundacle of. I guess we could just do a new type here. Fundacle. Name will be a string, right? And fundacle type is going to be an ER type. Cool. So now we can inspect the function here and see it has a name. That's excellent. Declaration name. Don't really know what that is. Can we destruct that? Whoa, okay. Identifier name, constructor name, destructor name. It's like a big name. Declaration, where you type. Ah, right. I think this is a complex type. Hey, Goofy Systems, how's it going? Since we have also, see, this will actually be able to parse C++ as well. Not that we'll support it right now, but, So let's go. I'm going to go on a hunch and say that identifier name is the one we want, right? So fundacle name is going to be lift name. Function name, like that. I'm just going to do that lift name. We get a name here, and we'll match on that. And if we get a name here, right, then we'll return that. And then for everything else, we'll just say assert false for now. Cool. So that worked on that side. Formatting the code. Now on the camel conversion part, now we have, this is gonna get exciting any second now, right? We're gonna have part of the ER now is function declarations. So we can do structure, I guess external from ER fundacle. We have a name and that, so we can do a structure. We will do, I think it's an extension that we need here. Not entirely sure. And let's go with that. Let's say we need an extension here. So HT helper expression, I think maybe. No, this makes the structure item. Where do we get an extension from? Do we have one? No, wait, it's a primitive. There you go. That's the one that I want. Taking what we choose. Anarchy's coming to town. Now, let's see. We don't have anything, but we need a valid description, right? And we have this val. So we can do that. So val make lock, we don't have any attributes here. We need essentially an identifier here, which will be the name of the thing. So we're going to call that lead fundacle name. And then we need to actually provide a core type. Thankfully, we already have a core type from AR, so we can just pass in the function declaration type. I think this is almost there. Wait, what do you want? You want to, okay. I guess you want to with lock like that. All right. Fun decal. All right. So in the AR module, we don't care about the live SQL yet, but we have, okay, ARML, line 25. we are getting here. What do we get here? Right, we have the function type, I guess. Pointer, type definition. What is this? To the ground, the disintegrators. It's a pointer to a type definition named doggo. Why do we have that there? That's right. We do have a pointer. Hello, Mohai. How's it going? Lonely and abandoned, washed up, left for dead, lost inside the deserts of every word you said, like a nuclear reactor on TNT, thinking about the times when you lied to me. Got upon my hook, I was just a name in your little black book. So we'll have a type def here, and I think this should just be abstract. We'll see. But we have a name right in here, so we'll do lift name, and that will be t dot name. I think. Woo. All right, things are starting to point. This is good. The fact that we're getting so many more prints here means that we're advancing, right? Through the many different definitions of types in C. But right now we really only care about this one, the small example. And this is blowing up. Camel 17. So it's blowing up where? Oh, here, 17. Because we don't have, what don't we have? We parsed a void that we don't have here. And so we're just going to call a unit on that. What else happened here? We also deepen with you. Hello, 404. You're gonna have to wait a little bit to find out, but soon. I promise soon. So we got char, bool. We got int and void as well. We have a pointer for sure. No, we don't have pointers. Right. So that's something that we'll have to figure out how to represent. Bam, 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 bam. I think we may want to have a pointer type. But for the time being, this should be enough. Almost there. And then, what else is the problem here? What are we missing? Show me. Func. Okay. If you get a function here, right? We'll have a function type. Even with you. And we're going to do a fold left, right? For on every one of the params. So we'll get our ac and a param here. And then we will start with the return, right? Value. So we want to actually call core type from ER on that one. core type from AR, right? Honestly, as soon as I got one, it was like, holy fuck. I stand in front of this thing for hours or sit in front of it for hours and do nothing, right? That can't be good. That cannot be good. Like, imagine, the environments where we as a species evolved. Do you think anywhere would we be sitting for 10, 16 hours a day doing absolutely nothing? I'm not saying this is good, because definitely there's some mind fucking happening, right? When you get out and it's like, oh my god, I'm not really moving, or everything's still quiet or still, right? But at the very least, there's some semblance of movement. Okay. Yeah, exactly. So, okay. We'll try to build a function type here. Which one was the function type? Tuple var ls class constructor arrow. Arrow is the function type, believe it or not. So for every param, right, we'll get a name and a type. And we want to just get the right type by calling core type from AR, right? So the arrow will be essentially from the type to the accumulator, right? And we're just missing the label here. And to get the label, we're just going to look at the name and try to build the label from there. But I forget exactly how we get one of these labels. Arrow. Arrow is here. AST types, arg level. All right. This is, okay, labeled, no label. I think we have a name, so we can just do labeled. Name. That should be good. We're just going to make the recursive. And oh, that matches unused. Excellent. So that assert will not happen, right? And if this works, which it did not, no, wait, it did. Oh, that's excellent. Oh, that is so cool. And so I guess we're going to do one more thing here. And we're going to grab whatever type this is pointing to, right? And we're just going to say core type from ART. So a pointer just will point to that thing. So that's not very good though. I think this one should be type name instead of lid. Da, 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 da. This is a sacred place. Okay, so we're just using it there. Are you ready? We're gonna do an promote, auto promote, if I can type the thing. Cool. So I have this C code, right? I'm gonna go into our test folder, right? For basics. And I'm going to our struct folder. So here I have that little bit of C code, right? It's not crazy. It's just, it renders like shit here. But, this could be some C library that I want to use from ocaml, right? Now, if I run to an exec, and I think I can go all the way down to I guess I need to really do this, right? Build default CLI main, right? I can say use this, right, and generate bindings, right, for that, and call them cool stuff, right? And then it does something, and then I get some files. I get my cool stuff ML, which, oh my god, looks like that, right? And we have some problems here with the new lines, but you get what I mean, right? And then we also get this camel cool stuff. And this, I think, is even more interesting because it includes functions, right, automatically to convert between these data types, between the C representation and the ocaml representation of this value, right? So we are just missing here a function that wraps this C function so that when it takes in a value, right, from the ocaml side, it converts that value into the right C representation. And then it calls the actual C function. And then, of course, depending on what the function does, maybe it doesn't return anything. But if you had a function that returns one of these doggos, right, then that function will also be generated and will automatically wrap and convert that C doggo into an ocaml dog. And that's... I woke up at like 1 in the morning today. I couldn't go back to bed, sleep. So I prototyped this instead. And, you know, it still has some errors here and there, but I think it's a promising start. And the nice thing is that we can actually use this, right, with any C library. So it doesn't have to be a shitty tiny example. It could be that we use it with like libsql, right? And what we get out is automatically sort of created bindings and the C wrapper code. So you can bring your C, your header files, right? And we just generate these things for you. That's sort of what we're doing here. The idea would be to get this in nice shape, eventually have a nice rule inside of Dune. So you can just drop in a header file if you want, and you can say like bindgen for this file, right? And that's it. It just generates everything for you. Or if we want to, we can say, okay, we'll publish packages, right, for these different libraries. And the only thing the package does really, right, is just say, here is the header file, right, and the Dune file that generates the right code using ocaml-bindgen. There's of course a ton of edge cases and things to figure out, but you got to start somewhere. So this is where we are. Okay, so one thing we're missing here in the camel side, right, is that when we create the primitive, we want to actually give it a name, right? So we need to pass in a prim here. Hey Kizal, thanks for the follow. And really, so what here? I don't know where doing. Okay, so essentially we want to do this, right? Camel, fun decal, right? Okay, something blew up. Dune permission denied. Where am I? Oh, I'm in the wrong room. Okay, that makes sense. There's no reason And no rules. I think I might need to go back into basic struct and remove some of the stuff. Camel, cool stuff, cool stuff. The hell is going on? Dune permission denied. Why? Hey, Paradox. So what I recommend is to build things, right? Build stuff that maybe nobody will use, but you want to see out there, right? Could be libraries, could be apps. That could be also just fixing things that are broken in other people's libraries or apps, right? I think the more you do that, the more you will be exposed to different styles of coding. And I'm not saying like object-oriented or functional, but rather different ways in which people build. Because you'll share things you build, and people will say, oh, why didn't you build it this way or that way? And if you fix somebody else's stuff, then you'll get to see how other people build. So a lot of other professions, other engineering disciplines, right? They do a ton of reading, right? Observing other people's materials, right? Like, I don't know, civil engineers or architects, right? They get to sort of learn to appreciate existing buildings, existing sort of designs. And we don't really do that a lot, right? But I think by building, you will get close to seeing a lot of code. And slowly that's going to actually help you understand what are the things you like doing or not, what patterns you like, and so on. That's going to make you a better programmer overall, I think. So yeah, go build. Doesn't matter the language, doesn't matter the platform. Just build. All right, I missed the Dune file there. There we go. There we go. That's starting to look better. It's the bones of the enchantress. Spellbound surging through the night. Goofy Systems, yeah, I'm on a walking pad. I've had it for maybe a week now. Last Friday I arrived, I think. Or maybe Monday. I forget. I think it's good. I think it's better than just sitting. It is a little funky at first, especially for like typing and so on. But after a while, like let's say the first half hour or an hour, your body just puts the walking on the background, right? And that's it. But I guess, I don't know, your mileage may vary. Because I do a lot of reading, for example, or going in the metros, on buses and stuff like that. And that sometimes means I read while I walk, which is a bad idea. But maybe that got me used to this idea, right? Like this mode of operation. Okay, so we have that. I think we can calm down this line over here. Oh, hey, Marek, how's it going? Thanks for the raid. We just got something really cool up and running. So y'all, I'm gonna show this to you in a second. But first, Marek, how was your stream? How are you? What were you building? Pain. That's good. Yeah. You build pain. Release the Kraken has 11. Okay. So we're building here this thing called ocaml-bindgen. And if I do ocaml-bindgen, you'll see it here, which is the link that I dropped on your stream, actually, Marek. And we just got it to do like 80% of what we wanted in the README, which is if you have some header like this one, where you have a definition of a struct and some types and some function declarations, right? So we actually can generate both the OCaml code, right, that matches that definition. So you can use that, but also the C shim that you would need to write by hand otherwise. No, we took a little detour. Like I woke up today at like 1 in the morning, couldn't go back to bed. And I was just thinking, maybe I should just prototype this for a little bit and just, it will tire me and then I'll go back to bed. But it did not happen. So we'll do like the 80% we need right now for here. And then we'll go back to 30 and just have something to alternate with. And right now we have it generating this, right? And also this. So both functions to convert from the OCaml representation back and forth from the C representation. So the last thing we need to do... No worries, no worries. Hey, like, yeah, go for it. Raid and run is fine. Thanks for the follow, Paradox Pister. So we're going to add now this, where we will be taking an OCaml value, calling our translation function, right? And then actually calling the C function, right, with that doggo. Nice. Whoa, 900 followers. Damn, so close to 1K. Actually, I need to double check if that C code is generated well or not. Camel doggo off value. Okay, so we have bug here. This should look like this, right? But instead it looks like that. It's no big deal. If we go into our C file, we have a small AST for C here, just for the things we care about. And the off value does the malloc, right? And then instead of doing store field, we want to do an assign, right? And then we'll do var is going to be name. No, var is going to be X. And is it going to be var? No, I think it's going to be just the axis. Let's look at the API we have here. Field access, yeah. So we just want to have field of var, right? And that's going to be field.field name. And then the value will have to be a little more complex here. It's going to be a call. Right now we'll do val int, right? Actually, we want field. We want to get, no, val int, and then we need to call it with a call to field, right? And one of the parameters is going to be the index that we want to use, right? And then the other parameter is going to be the variable that we want to use, which is the camel value. I think that should be that. Most likely it's going to be missing something, but let's see. Fight for freedom, fight authority. Hey Arbit, I am on a walking desk here. It's a rather new thing, and I'm loving it. But it is a little wonky, and on camera it looks like I'm just like moving around. Fight for freedom, fight authority, fight for everything, anything, country to me. So why don't you like this? Oh, right. We want to do that. Bunch of errors. That's fine. Woo, excellent. So that looks better, right? We have some doggo, which is x, and we'll do x many is going to be equals to the first field, right? Which used to be that. And 1 is going to be that one, which makes sense because these are camel values, so we cannot access them by name. We need to request with the field macro. As soon as we have the type information, we'll be able to sort of wrap this with the right function. So doing test, auto promote. All right, but the return here should not be camel return. That should just be return x. Nope. Better. Por los errores, Gloria, nos mentimos tanto. Time and again, she repeats, let's be friends. I think also in this case, since we have a pointer, we actually want to do not access like that, right? Field, but a pointer field. Like that. Okay, so just to finalize the vertical slice, we're missing two things. One is to be able to generate this from just a header, right? And a doing rule. So the header will be like bindgen, and then you put the name of the file, right? And then it just generates the thing. And the second one is to compile it and run it, right? So to have an example that actually calls through the FFI and does something. Nice. Much better. Oh, okay, so maybe three things. We still need the function that wraps the function, right? And I hope we have enough information here to do that. Let's say ER, we have an ER here for a function declaration, right? Fundecal. And we can do shims wrap function. So we can make one here. Wrap fun, we get a fundecal, which is probably a better idea to just destruct here. No, it's fine. And we want to declare a C function, which will have for return type Thank you, folks. Cool. Nice. So now we can do C function, right? And this takes a few things, and it takes a function return parameter, which is not the same as this one, right? This is an AR type. I guess we'll have to convert it into a function type here. See you 404. Have a good one. How far? Where are you, by the way? Yeah, like 6 hours of difference. Somewhere in like Kentucky? Is that like in the middle of the U.S.? I have no idea where Kentucky is, but I know it's like California left, New York right, Florida down, Alaska up. Hey, Terrence loves your mom. Thanks for the follow. East side or countryside? Not too from Dylan. Okay. Cool. Internal resistance. Thank you, thank you, thank you. Years of coming down. Wait, what? Oh, this is the alternative version. Hey, Vinci. Hivini, Hividi, Hivinci. And so far, so good. This was the first Megadeth album I ever listened to on a cassette tape. Okay, so getting distracted again. We're in the C side. Want to create a function? We have a return type, right? We want to map that return type over. So I think we can just call a function here, type from AR. And we'll have some params, right? That we can just do that with. We will have a name here. And that name will be pretty much the same, right? Camel. And then we'll grab the fun decal name. So we'll prefix with camel, right? The bindings that you have there. We could probably call this ocaml-bindgen even. But let's start with camel. And for the body, right? This should not be that hard, right? So we have a number of parameters. That means that we will declare how many params we have. The params will all be values that come from the ocaml side, right? Actually, that makes this much, much easier. Because we just need to do a list map here, right? And we get a param, right? And for every one of those, it's going to be a pointer to a struct called value, right? And we'll preserve the name it has. So this actually has a name and then the type there. Great. We still need this one, right? We don't know what the type is, but we'll respect whatever the type they want. And here for the body, right, we want to first, we want to call camel params to declare this is how many parameters are going to be passed in from the ocaml side. So we'll do a call to that and say camel params, right? And we'll pass an int here, which will be the length of the function params. I think, did we do that? Int like that? Yeah, okay, so that's complaining because of that one. Okay, let's start by just saying you're gonna return an int or void. Do we have type here? Funret prim. Okay, we can do prim of void. Cool. So we focus on other things first, and then we'll come back to the return type. That's starting to look nice, right? We get that code. It takes the right parameters. It's a value. It doesn't really need to be that, though. I think it just needs to be value. So we can just do prim here. That makes more sense. And then after that, what do we want to do? Let me close a few things here. We want to convert our param to the right type. As we're just gonna assume that we have that function around, right? It should be available from somewhere. It will be defined in this file. Okay, so we're gonna grab the parameter, right, and we'll do a declaration here. And we're gonna declare, right, that will be I think we need to do this for each one of the params. So for each one of the params, we're going to convert them into the right type by calling the right function, right? So we'll do that. So we'll do like that. And then in here, we'll just call list map, right? And we'll get a param. And for each one of the params, we might actually want to do multiple things, but I think we just want one right now. So we want to do a declaration, right, of a pointer. Okay, I guess we're gonna have to grab the type after all, because we need to know what type to convert this thing into based on the parameter type. Wait, but the type would be always value? No. We have the actual type. We do have the actual type. Okay. We'll do this for now. And then we'll call this name, right? And the value is going to be a call to the right conversion function from value, right? And it will be something like camel underscore, and then we'll have name, and then we'll do of value. Something like that. Let's see. Okay. Not terrible. Starting to get there. And that means we want to pass an argument, and the argument is going to be, right, a variable called camel name, right? So then we'll be passing the popper straight into the function, right? Camel popper of value. I don't quite like that it's called that, because that should be from the type, not from the name, right? So I think that we will have to do type. Cool. So this will give us a conversion, right, from all of the parameters, from the camel value to the actual magic value. And we'll get the magic value once we process the parameter type. Terrence, no, I just use NeoVim, and it's a rather new thing as well. I've been using Vim for like a decade, a little more, and maybe a year ago I switched to NeoVim. It's been a great experience, but I don't really use point and click tools in general. I mostly stick to terminals. I just got used to them. It's hard to get out of them. That sort of thing. At the end of the day, use whatever actually gets the job done, right? Exactly. Focus on building. Chances are that the editor is not the thing holding you back, right? It's like so many people build amazing things on VS Code. And like people build amazing things in much, much, much less, right, than the editors we use today. Which is also why I barely configure Vim. Yeah, even Notepad. Even before Notepad, right? Ed, Nano, all of those really old editors. Yeah, it looks fun. And if you think it's going to make it more fun, right, then I think that's worth it. Because if you like building, you'll spend a lot of time building. And you will want a tool that you have fun with, right? So I think we're going to just define a camel prefix here. Like that. So we can actually just use that instead of redefining the same string everywhere. So if this works, that means we should go to struct h, right? And if we add another parameter like bool what? Yeah, look at that, camel what? We get that out of there just fine. Bool turns into an int? Fuck no, that is wrong. Charge char, void. I don't know, I don't think we can do that. Yeah, it's a unit. All right, whatever. This will be broken in so many ways, but that's fine. Hey Pagusar, how's it going? Good to see you again in chat. So bindgen actually lets you create bindings, right, to C code. Or not lets you, it creates bindings to C code for you. You give it a header, right, and it creates the OCaml code, right, and the C code that lets OCaml interact with that, that library you want to use. Exactly. Let me show you. So we have this little, right? Oops. 1 second, the thing just decided to stop moving. Play. Don't go to automatic mode. No, just go to manual mode. There we go. All right, so this is our header, and it could be a much larger one, right? It could be like libsql h, right? With a bunch of functions and whatnot. And struct h, right? When you run ocaml-bindgen on this header, you get a couple of things. Let me show you. You get a file called structml that looks like this. So you generated a type based on that structure automatically, and it gives you an external, right? That has the same parameters as the C function, but it also generates the C code, right? That we can use to actually call this function. Because you know how in OCaml we can't just call C functions, right? Because we have a garbage collector. I'm really happy. Yeah, you get tempted at trying OCaml. It's gonna be fun when you do. Finish that thing. We'll be here, building. So now, like at this point, we had two functions generated, which is like this structure from and to the OCaml type automatically, right? And now we're generating the wrapper needed to call this function, which is not that hard, and it's slowly starting to take shape here, right? Like we convert the OCaml value into the right value, and then we call the thing. We're going slowly. Oh, thanks. I appreciate that. What? We welcoming? Get the fuck out of here. Okay, so where were we? Fuck, I lost my train of thought. Right, we need to actually call the function name, right? So we need to call fundicle name, right? And we need to call it with all the params it has. So list map, right? Fun param. So we'll just do var para, right? And we probably want to declare the result of this thing. Its limitations. Okay, so that's not too terrible. We have a function. We get the popper from camel. We declare the parameter, right? We call our magic value converter. We get a popper on the C side. We call the function. We get a result, right? And then we will want to figure out how to turn that result into an ocaml value and do camel return. So this would not be return. This will be camel return, right? Which I think we can define because we're going to be writing a couple of those. I don't know yet how we're going to do that, but it's definitely not going to be like this, because we're going to have camel. I guess we can do camel params, right? And do camel local. And we'll just do var result. Nice. Gotta love it when you do the refactor and everything stays the same. Okay, let's get the return type. So we'll do C type of ER, right? FN ret. I'm off to meet my maker. I'm on my way for sure. In the air, this will never hurt. Catatonic state. All right, that blew up. Not very good. Bam, bam, bam. There we go. Doggo is back. Excellent. So now we can just use C-type here. We don't even need that. And for the return, we can literally match on the return type, right? I think I would like to preserve the void instead of turning it into a prim like that. So we can actually match here, right? And if we have void, right, then we don't need to return anything. I guess most cases we will know Right, because the return of the function will be that. So if it's void, then we can just call the function, right? I'm just going to put that there. If it's void, then we'll just have the function call, right? And then we'll have ocaml return, right? 0. So there's no return. If we don't have a void, right? Then we'll declare a result, or actually assign, because we already have a result above. So assign. We don't really know how to save that yet. Yeah, that looks funky. I think it will be a little better with a little less indentation. So we'll just pull that out. So here we can just do declare params, right? And then we'll do declare, maybe declare result, right? And then we'll do transform values, right? And then we'll do call and return for that bit, right? So then we'll have a little list at the end that will say declare params, and then maybe declare result, right? And then transform values, and then call and return. And we can just do list flatten here. And hopefully the formatting is not going to destroy that. No, that looks reasonable. Test out to promote. Great. And what do we do here? We generate function wrappers. Feed generate function wrappers. Okay. So we have our function wrapper. We're missing two things still. First one is, I guess we could skip one, right? The rule, that's more of an automation thing. But we would want to have a little program, right, that we run that calls to these bindings and does things, right? Cool. And we'll have a doggo C as well, right? So let's close everything here. We're going to go into example. And we actually want main here ML that will actually use that file. Cool. So doggo has this stuff, right? And then doggo C will include, right? Doggo H. And we'll actually implement this function. We don't need to do much, right? We can just do printf here. Just doggo says, right? And we can do popper any, right? It doesn't have to be smart, just has to do something. So in our do file, right? We're gonna do a library here, right? Which actually an executable. And the name is gonna be example. And then we want to have a little rule, right? That will generate some files and do auto promotion so they end up here. Ho ho ho! Speedodon raiding me. Hello everyone, how's it going? How's the stream going? How's the Krakens? Who's this? Darklog17. Hey, how's it going? Oh, amazing! Thank you so much for joining chat, folks. Happy to have you here. We got Blind Kamikaze. We got Lemnine. Oh, I know this guy. Yeah, you know this guy. If I ever bind you in Spirit stream, then you probably deserved it. And I can also bind you here, so behave. Hey Chaz, how's it going? We are here writing OCaml. We're writing ocaml-bindgen, a tool for generating OCaml to C FFI code automatically from C headers. And we managed to actually get both the OCaml side and the C side, right, generated already for some use cases, for like this, example we have. And we're about to see if it runs. Papacorno. Epic music indeed. Yeah, thank you so much. Yeah, I have a walking desk here. It's a walking pad C2. And I've had it for maybe a week now. And I love it. It's great. And don't worry, we don't do that kind of typing here. The typing we do here is pretty sensible. It is built for shipping. Yeah, we don't. Honestly, it's like, this is no Haskell, folks. As far as types go, we're closer to Go than we are to Haskell. And we keep it that way. Will do. Have a good sleep, Speedo. See you soon. For anybody not knowing this, Spiridon actually features me as well. Huh, look at that. I'm right there. This is me when I don't have a beard. I figured that everybody else was a bearded person, so yeah. Thank you so much. I appreciate that. This beard likes the beard. Yeah. Okay. So what we want to do here is tell the build system, hey, there's this magic little tool that I want you to run on this header file, right? And grab the outputs and put it right here on disk. But doing can be quite tricky like that. Hey, Chas Watkins, thanks for the follow. So we're going to have a look at a little example that I had. Where are we? From here, right? And I have this. This is how we do it. Copy, right? Just gonna come here, paste that. And the alias here, we don't really need an alias. We just want a directory, and this is gonna go called libdoggo. And we don't need that, I think. No, I think we do need dependencies. We need doggo h, right? That's the file we need to depend on. The directory requires directory targets. Okay, so I need to go into Doom project and say directory targets. All right, that's the thing. So we'll use that. Cool. Name example doesn't exist. We can call it main. All right, cool. So let's just check that build folder, right? Default examples. Ooh, that's no good. It didn't really put anything there. Why? I think we might want to have an alias here. Perfect. So when we do all, then it always gets built. And what we want to do is actually run a binary, right? And this will be bean ocaml-bindgen, I believe. And we can run it like that, and it should probably blow up. Yeah, it did. Perfect. So we want to tell it to use doggo h, right? And the name of the library is going to be libdoggo. And if we do that, it blew up. Huh. Failed to produce directory, libdoggo. Oh, okay. I guess this will be libdoggo ml and libdoggo c. Oh, camel. I think that makes more sense because of the prefixes we have. All right, so nice. We have the generated C file. We have the generated OCaml file as well. Char string, that sucks. I'm actually using Clang bindings, so we're actually parsing the C code with Clang, which is the same thing that Rust bindgen does, which I think it should be much more reliable. Link to the desk, trend mill. We need to burn some foul coding. Yeah, sure. Let's see. Walking pad. It's this one over here. And we're going to add a command. Add treadmill. I use a walking pad. Cool. Okay, so that must mean that this main file, right, has access to Doggo. Woo! Look at that. Okay, almost. How do we do this? All right, we have this pointer garbage here. We probably want to get rid of that. Not here, though. We want to get rid of that in the AR, in the ocaml side. So ocaml here, we get a pointer of a T, and we'll just say, all right, everything really is a pointer in ocaml, so we'll just use the T. And I think it's going to be broken for a million reasons, but all right. And we also have some problems with that. Oh, come. And I think I'm using that somewhere. Probably in the CodeGen module. Actually, no. Where's the pretty printer? We have one in CodeGen, right? Yeah, here. This thing. This garbaggio. Go away. Cool. So now we just need to remove it from here. And from here. So in this case, it's not really overwriting the Dune file, is it? No. Okay, thank God. So we will have to do something. I don't know how we would do that. Maybe this is a tool you run at the top of the repo, and it just generates all the Dune files for you. We need to figure out that integration with Dune better. Il popcorn. Nice. So Doggo is the library we want to bind to. Camel Doggo is the bindings. We have some problems here. All right, let's see. So Camel Doggo, see, what's the problem? What don't you like? My God, it doesn't like fucking anything. Wait, it didn't rewrite this? Oh, forgot about that one. Camel Doggo. What don't you like here? Why do you get a struct value? That's not the right thing. This should be a value like that. Okay, so we can go there, go into CML and say of value, right? Parameters is not a structure value like that. It's just a prim. And my Doggo C file is also broken. What are you talking about? It's right there. Cool. better. So line 11, camel local 1, camel x is undeclared. But this is how I declare new variables. What are you talking about? What in the hell are you talking about? Let's go into the gluon syscall, right? Okay, you. Literally. Oh, okay, sorry. We're missing all of the fucking headers. This is why it doesn't work. Because we should have all of this stuff right there. Probably more than this, but... And I guess, yeah, we need to actually put this in the... Okay. So we'll need to add includes, right? Let's do that. We will need here definition sc include, right? And we'll just do the dumb thing. I'll just say string here. So we can do c include, right? Like that. I know, this is not going to work for everything, but it's okay. Watch him become a god. Would people feel? What? I am flattening. What are you talking about? There you go. So that builds, and now load. This thing should have headers, but it does not. Oh my god. Where are we? Here. Ba-da-ba. So we're building binding generation, right, for OCaml. So if you give it the header from C, it generates all the code you need to be able to talk from OCaml directly into the SC code, right? The 30-second pitch of OCaml is like, imagine if Go had a decent type system. It's garbage collected. It is crazy fast. It has very good C interop, right? And with libraries like riot ML, you actually get Erlang style concurrency. So you can build things across multi-cores, kind of in a very similar way that you do with Go routines and channels. Here we have processes and message passing, right? It can be faster than Go in some cases. Like the long time adage is that OCaml gives you 50% of the speed of C, right? Without having to do anything. But there's companies that are building real-time trading software in OCaml. So you can make it run really, 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 really fast. What problems does it solve that Ghost type system doesn't? Okay, you're in for a treat. So OCaml implements a proper sound type system, right? Based on Hindley-Milner inference. So there is no type annotations anywhere in the code that I have here. Not at all, right? Like formatting and so on. All of that is inferred. Sometimes we add them more for documentation than for anything else so that we, okay, we know this or that thing. But your entire program is type safe. So there's nothing, right, that could blow up under your feet unless you explicitly fuck around with those things, right? Which you could do it. So that will be one big thing. The type system has algebraic data types, so we work with records and variants, right? Enums that have arguments, including records inside them. We have a module system that is really interesting and very powerful. But honestly, just having the ADTs is already an order of magnitude, if not two, better than whatever type level modeling tools you can use in Go. So the 50% of the speed of C is basically a reference to how the garbage collection run and the fact that OCaml compiles to native code, right? So the garbage collector is super small and very predictable, right? And it can be tuned to work very nicely or not work at all in some cases, right? Like you can actually work in a way with OCaml so that you do your allocations up front, right? It's a very austere, harsh way of writing OCaml, but you can do it. Yeah. So one way, for example, is I have this file here where I have defined an AST for C, a very small subset of C that I care about right now, right? And if I wanted to say, okay, I want to generate the types for all of these modules, right? I just create an interface and tell it to insert the infer types. And these are all the types the compiler knows about without me having to tell it anything, right? No, I understand, Lemnia, no worries. I'm not taking you as a troll here. I think that if you're coming from Speedo Stream, you're good people. Chas, yes. I've written a lot of Erlang. I've been an Erlang programmer for a little over a decade, and I've done a lot of Elixir as well. And I feel like that is the right way of programming multicore. If you want to do multicore with shared memory parallelism, you're going to shoot yourself all over the place, right? So processes and message passing just make it so easy. So let's say, Lemnian, one thing that you can do in OCaml very, very cheaply, right, is make a lot of illegal states unrepresentable, right? You can define what your data should look like, and in your data types, actually rule out different invariants, some things that should never happen, right? Which in Go, you probably recur to runtime checks, right? Assertions of different kinds. Whoa, thank you so much, Chas. That's amazing. I really appreciate that. Thank you. You're in the right place, yeah. I'm happy to hear that. But this is not to bash on Go. I haven't written Go professionally, right? I've written toy projects, but I've read a lot of Go. And I really appreciate the mindset of the community, right? I really appreciate the standard library being so thorough and full, right? And these are some things that I'm really trying to bring, right, into OCaml. For example, you know the bubble tea project, right? This thing. Right? We ported this to run on top of Riot. It's called Minty. And it does the exact same thing, right? And it was surprisingly easy to do, right? But it required sitting down and reading a lot of the Go code and trying to understand the patterns they're using and so on. Translating that not just to OCaml, but also to the Riot runtime, right? And when I show you the code, Minty, right, is maybe 300 lines of OCaml in total, like across these files. It's very, very small. And that includes some interface files, which are just definitions of types that are useful for us to communicate to users of the library. Hey, if you want to see all the types, you have them here, right? Of course, we also build like components, leaves, we call them, and we have a bunch of examples here. Some of them are kind of nice, like spinners. Let me show you some of this code, right? If you go into the spinner, we have, this is it. This is the whole thing, right? We have the spinner declaration, which this could be a single line if you really don't want to use an auto formatter, but we don't care. You have a little update function, right? Yeah, absolutely. So this is this is gonna sound like a low blow, right? But we don't have null, right? In any way. So if you want to have a value that is optional, like let's say maybe name or optional name, you just use a none or a sum. Yeah, like in Rust. In fact, Rust has a type system so close to OCaml, or heavily inspired by OCaml, primarily because Rust was originally written in OCaml. Rust is sort of an excellent example of what the OCaml type system can do for people. Because like 80% of what you can do with Rust in the type system comes from OCaml. We do, but we don't really use them as much in terms of being monads and using bind operations and stuff like that. There is a part of the community that is very into monads, right? And we have type tools that can get complex. But there's a part of the community, especially the one that's streaming a lot lately, right? Where we're really trying to focus on using the least amount of type safety that will get you there, right? Type things because you can. Like typing things because you can is probably a bad idea, right? Type when you should, right? Not just because you can. So, a long time ago, I wrote Caramel, which was a compiler for OCaml to run on the Beam. And this project is abandoned now. It's been like 3 years at least. But since then, I've been interested in bringing type safety into the Beam. And it's such a hard thing to do because the Beam is so dynamic, right? Like Louis, right, the author of Gleam, is doing a fantastic job at sort of scoping what is practical type safety for the Beam. It's absolutely amazing. But the kind of type safety that sort of is flexible enough to build interesting things, I think, like OCaml, is hard to bring onto the Beam. Exactly, like GATS, stuff like that. So instead of pursuing the avenue of going like from OCaml to Erlang, I'm going the other way around now. I'm saying I'm going to grab things that are good about the Erlang VM, and we're going to bring them into the OCaml runtime. Hey, Senor Kai, thanks for the follow. And that idea, bringing the good things about the OCaml, sort of the Erlang virtual machine into OCaml, that is what Riot is about. It's a tall order. We have a good prototype by now. It's been maybe 4 or 5 months since we started. And the Riot scheduler already includes a lot of interesting things. So let's go back to the practical Minty. So for example, pattern matching on events, right? This is fundamentally easier because you know at compile time what are all the possible events that you will ever get, and discoverability, right, of what are the things you can pattern match on is aided by the compiler. So when we go here and we type event, and let's say you're missing this line, right? The compiler will tell you, hey, you're missing this and this and this and this and this thing, right? So you can either like copy that straight from the output or ask the LSP to complete things for you. That would be one thing. And that alone can help you model applications, right? In a way that you never forget about handling some of the cases. You can explicitly say, I don't care about the other events, right? Like we do here. But that's it. Since we don't have the same kind of dispatching that Go has, right? By associating functions to types and through interfaces, right? Then it's also a lot simpler to know where to look for things, right? You have a sprite. In this case, we have a sprite here. All the functions for sprites are in the sprite module. you can't really do that in other languages that don't have this kind of type system that is total, right? And by total, I mean you grab the entire program and you do static analysis on the whole thing, right? If you don't have that, then you will always be missing something. You won't be able to say, we have considered how this type is defined, how it grows, how it shrinks, etc. And we know now that these are the only possible things it has. And in C, anything can be null, especially if it's a pointer, right? So that already tells you that if you had an event pointer in C and you wanted to do a switch over that, right? You first need to check if that pointer is null or not, right? And even if it's not null, does it still point to the memory, right? To memory that matches the data type you want? You don't know that, right? When it comes to error handling, we have some interesting patterns, right? That we use results. We also have exceptions, but we use them less. Not that they're better or worse, they're just different. And we have some, one kind of type level tool, just like an enum, but it's like dynamically grows based on the usage. Again, this is completely safe because the compiler will track all of the uses and put together all the possible options, right, at compile time. But that allows you to just return errors from different places and let the compiler group them together for you to handle them later. It is not all, it's not all great. The syntax of OCaml is weird. It has a lot of weird edge cases. There are so many things that I just dislike. Let me give you an example. I am importing SERDI, right? SERDI is a serialization library. And in the JSON format that I'm writing, right, I have some code that looks like this. Look at that. That is weird. What the fuck's happening there? What is this padding, right? So yeah, there's a lot of things in OCaml that are like, ugh, okay, I guess I'll put up with this, put up with that. But seriously, they are completely worth it considering that most of the time, if it compiles, it does the right thing. Because we are putting effort into making sure the types describe what the right things are. Whereas in most of the languages that are typed, Java, I've written a lot of Java as well at Spotify at some point. When you compile, you just know that maybe the variables are instantiated with the right type, hopefully, if there's no like weird casting going on, right? But then you still need all of the assertions, all of the runtime checks, right? Yeah, the tooling is getting better every day, which is really good. It's not quite there yet, but it's improving. An elixir for OCaml that provides an idle syntax. Well, do not tempt me. Do not tempt me. I do feel OCaml could benefit from a Ruby-like. Next, Jose Valim. No, it's all right. I am Argentinian, though, so it's like a neighbor. Oh, thanks for the follow, Lemnian. What the fuck happened there? The tooling of Go is fabulous. It is absolutely fantastic. Yeah, I mean, I think there's no reason to discard the entire platform, right? The Go platform. Just because, like, oh, you don't like the types. Like, there has so many good things in there. So many good things, right? So yeah, let's learn from the best. And Go is one of the best, right, at that. Okay. So we have some issues here. Where were the issues? right? Bam, bam, bam. You can, by the way, do type annotations in line, but also separately. Let me show you. You might know this already, but just in case. So here's a version of inlining that annotation, right? So we say, okay, here's some opaque variables. Here's the argument. There's the type. This can get tricky to read if the thing is big, right? But you can also do this, where you say serialize is a function, colon, this is the annotation, right? And then you have the body. And I really, really much prefer this version because I can distinguish between like, okay, that signature versus this is implementation. And there is no penalty for doing this. It is exactly the same as the other one, performance-wise. Cool, nice. Okay, so one thing we're missing here that we absolutely have to have is the include to the library we want to use, right? And it's kind of funny we missed that. It's like, oh yeah, we're going to use Doggo, the library, right? But we don't include it. So let's go to CML, right? And we have this stuff here. And the one thing that we need above all, right, is to actually have the AR's libname, or I guess header file. So we're gonna go there. I'm gonna change that to have like header file. So when we build that, we also include it. Lift name header. I guess we can call it header. And now we can go into bindgen. And here we have a file. So we'll just say header. It's going to be file. Include Doggo. Better. Has a problem still, right? So maybe here we will just do, for now, like that. So by the way of doing it, but it will get us where we need to go. Okay. So looking better. Not so terrible, right? Just a few errors. Camel X param. What the fuck? Camel param 0. Camel param 1. What? Why is that 1? This should be camel popper. I'm confused. We call camel params. And we pass an int? I think we should just pass the params. Or maybe list map, right? Fun, name, type, name. And this will be var. That should compile the same. Right. And we need this not to be that. We need this to be camel, right? Like that. So this should be camel popper. Better. We're getting there. Expected a what? Camel 0. How to use camel return. Camel return 0. Oh, just that. Okay. So we're going to do var. Okay. That compiled. So if we do doggo, we don't actually see anything. I wonder why. Let's see our doggo module, right? We have this 11 out of 10 majestic AF function, right? And we want to call that here, right? I'm going to say pupper, and we're going to pass in a doggo that says many 2112, and wow, the char is going to be X. Oh, sorry, character. Okay, that built. It built. It has built. Okay, let's see if it runs. Ready? Manual. No, examples. Main. Yes! Segmentation fault. All right, not very good. But we can do ocaml, run param b, and we do LLDB, and we'll do debug. No, build, default, examples, main. And I forget how it goes here. R for running? Yeah. We will be die for metal. Fighting for where and steel. Segfault for the win! Solid function name. You need to use that. Yeah. Majestic AF. Fun fact, there's 2 libraries in OCaml, one called Angstrom for building very fast parser with parser combinators, which is great. I personally don't like combinators, but the library is great. And another one called Faraday, which is for writing serializers that do no copy, essentially. Or, I mean, no intermediate copying. So there's a lot of libraries called AF. You got HTTP AF, WebSocket AF, right? That sort of thing. I am not making this up. HTTPF. Us. Okay, let's carry and check chat for a second. We should re-implement Beam using VB script. Excel macros will be so faulty. They are, actually. Like, I know a lot of Excel macros that crash, right? But I've only seen a few that crash Excel. Playlist is great. Thank you so much. Brave Sir Richard. How the hell do you walk and type at the same time? That's like magic to me. Brave Sir Richard. Everything is in the hips, right? If you can walk with your hips, then you can keep the rest of your body kind of stable. The secret. Yeah, exactly. Okay, so something is wrong here. And I think it's because my Sifu is not very good. So, okay. Anybody knows a lot of C? You need Argentinian tango hips. It does require a lot of hip movement, tango. So I think I'm just being a dummy here. But I also think that maybe I'm not. So I always go back to code and see that I've already written, right? that I know works. So, for example, oh, right, it's the other way around. Fields, field, and then the argument. Okay, never mind. We are being dummies here. So field is var, and then the index. Like that. Woo! Dargo says 2112! So, yeah, end to end. End to fucking end. Ocaml-bindgen works. I'm gonna clip that. So here's the thing, folks. We have this vertical slice, right? We can create some C code and just many work, right? You get a free set of heaps with every stake. Damn, we definitely have a lot of heaps then. I would say though, I don't know what sorting does that someone would impersonate. I know of him, right? But I haven't watched their streams or anything. Talking stake. This is the important matter, all right? Folks, seriously. We need to discuss this. Brazilian steak is amazing. It is some of the best steak I've had in my life. It is so fucking good. Some of the cuts they have, like cupim, brilliant. Picanha bem mal passada, excellent. But Argentina steak's still better. I don't make the rules. That's how it goes. What can I say, man? They beat us at football. We beat them at barbecues. It's fair game. Okay. So we're going to grab that and say feet first end-to-end slice example works. And we're going to put a dog there. Dog! Hot dog or dog face? Just dog face. I think it's cute. Argentinian on treadmill serves beef with Brazilian sticks. Void matrix. If it ain't end-to-end, it's bullshit. 100%, right? Like, it has to be end-to-end. If it's not end-to-end, then something is broken. You just don't know about it. Banger. Leo, how do you get this emoji? I use Kitty, and Kitty comes with like an emoji search thingy and whatnot. It used to crash a lot, but it doesn't anymore. Okay, that was awesome. So we actually have a Discord where we're developing some of these things. And at 3:22, I commented that I couldn't sleep, so I started building this thing. So we started hours ago. Let's see when the first commit is. Initial commit 6 days ago, but there's like nothing there. Just like a README. That's it. So it took 7 hours. Seven hours. It took 7 fucking hours. This is not that hard. The 80% or I don't know, 20% that I did. It's just a matter of sitting down and doing the fucking work. No. That airline flavored ocaml thing, we've been writing for a couple of months now. But it started like that on my birthday. Like, how hard would it be to go the other way around? Just build, folks. Whatever the fuck you want to do, just build it. Sit down and build. Aw, thank you, folks. So, yeah, if y'all want to hang out, we have some discords here. The first one that I'm showing you is the ocaml riot one. And this is where we're building all the stuff, right? The web stack, dbcaml, certi, bindgen, and so on. You can do like Discord. But we also have one called the Caravan, and this is where like a lot of ocaml streamers hang out. And I don't see all the channels here. I have them hidden. There's like a ton of channels here. You can see all sorts of things, and you get notifications for people go live. And we have a reading group called Reading Rainbow. Oh, let me, and yeah, we are like dozens of us, at least 1 dozen. I know, right? Yeah. Classic name. And right now we're reading Essentials of Compilation. So people, this Sunday actually we go to chapter 2. We just started. So if any of you are feeling like, hey, I would like to do more compiler stuff, right? Or just, build my first compiler. This book is brilliant for that. And we're going like 1 chapter a week. We just started. So you can definitely come here and just make sure you have chapter 1 and 2 read for Sunday. Or, if you feel it's too soon, maybe chapter 3 for next Sunday. I wanted to write here. Book club. Yeah, we're doing a lot of work for that. You got folks. I need to do some shout outs here, right? So first shout out goes to Sabine Ocaml. She's running the ocaml.org team, doing a fabulous work at documenting things, having better tutorials for people to get onboarded, right? Having things that are actually practical, right? So you go into the OCaml language and you want to like see some of these things after you go through like the introduction. And these are written so like anybody can pick it up and start doing work and just like do things. So I absolutely love the work Sabine is doing. Excellent stuff. Then of course you have folks like Dylan Mulroy, right? And we'll do a shout out in just a few seconds. And there we go. Oh, I have to wait at 1 minute 30. God damn it. All right. That makes no sense to me, but whatever. And Dylan has created Create Melange App, which is a way of setting up a front-end application with OCaml using the Melange compiler, which lets you have a full interop with JavaScript and TypeScript, right? He even has a nice video where he explains how all of this works. And yeah, it's an amazing piece of tech. I love it. Super nice to get started. Hi, Sabine. Are you gonna stream today, Sabine? Not in the morning. All right. I have a meeting starting soon, so we're gonna have to rate someone fun. But before we do that, I will tweet about this. we're gonna twitter.com. So I couldn't sleep. And ended up prototyping ocaml-bindgen to generate bindings to any C library with just the headers and a little Dune rule. You can see this, you can find it here. But what I really want to highlight is this, right? You just define this, giving the C header that, then we automatically generate all this code for you. I think you missed it, Sabine, but we got it working. It's like auto magic. With some more work, we could start essentially binding to all of the C ecosystem. Sabine 14 Queen. Shrink. Sparkles. What? Isn't it carbon SH? Shrink. Ba-ba-da-bam. All right, chat, help me out here. Go make some noise. Ba-ba-da, ba-ba-da-na-na. Okay, chat. I need to jump in 20 minutes, so let's find someone we can raid. Right? And I have some lurking channels here. I think this one or this one? Yeah. Ah, we were lurking Spiridon and now we're here. No one's online? Seriously? Okay, we're gonna have to explore a little bit. Let's see what other folks are up to. Mercenary Mage. Okay. No. Lord Refa. What are they building? S9 Pepper. Oh, wait. Magatron just got on. I think we're going to go raid her. Starting stream soon. Oh, how soon? Okay, let's check also that other one. S9 Pepper. Because if Sunni's like in... Oh, wait. There you go. I can't hear anything. Okay, I guess we're gonna go raid Max. Raid. They're doing game development stuff. It's super fun. She's got a lot of cool emotes as well. That some of which I've made. Go have fun. Take care, folks. I'll stream sometime later. I need to write some docs.